what we're doing here is that there is just like the lens on a telescope. Okay, all these pieces of wire that you see going across, these pieces going across like that, those are actually at radio wavelengths, act as lenses, and they concentrate the energy from the sun onto the bottom where the wire comes out of the antenna. Concentrates all the energy down to that, sends it up a cable, into that cable there, into that box, where the modern electronics gets hold of that, sends it down to this receiver here. Okay? We then tune the actual signal that we're listening to. The signal is then fed into this box. What this box does is it actually takes the signal and cleans it up, digitizes, does all sorts of things we want. Then normally what we do is we take the signal from here, we feed it into a computer, but I didn't want to bring the computers here because you normally can't handle the data. So what I've done is I've fed it into an old-fashioned recording device. And as you can see, instead of looking at an actual picture of the planet, in this case, or the sun, okay, that's quite possible that there's some sort of an outburst.
So is this what's happening on the sun at the moment? So what does it measure? What is
essentially what it's measuring is if you were to listen, we can turn this one down. If you were to listen with your ear, that's all you hear. Now your ear just tells you that there's a noise there, but this device actually converts that noise into useful information. But essentially what we're doing is looking at the variations in the noise that come out from the sun. At the moment, like today and yesterday for this whole last week, the sun is what we call it, it's a quiet sun. This could also be interference from these guys, but that doesn't matter. We are at the moment in a period of quiet sun, so this week there's been no storms on the sun as such, no solar flares or anything. But normally if there's solar flares, the recorder goes mad like this and then it dies down. Then what we tend to do is we take an optical telescope. Now, you never use a telescope, your eyes, binoculars or anything to look at the sun. You will burn your eyes out in a tenth of a second and you'll never see again. You cannot do that. We use specialized telescopes that have got special filters on them and allow us to actually look at the sun at different wavelengths of light. Does anyone know, is the sun made up of many colors or just one color? Many colors. How do you know that? No, you must know.
High for temperatures.
Okay. How can we, a simple experiment, how could we prove that the sun has got many colors in it? Yes.
To look at fire maybe?
No. Fire is something you got on Earth. But
isn't it with water? If it shines on the water, the rainbow.
Exactly. It's the rainbow. The rainbow is generated by the sun, isn't it? If there was no sun, we wouldn't see a rainbow. But what happens is the light from the sun goes through a raindrop, a single raindrop, and it breaks that color, the sun's light, the so-called white light, breaks it up into all the colors. Okay, from violet to red. Okay, there are also colors we cannot see. There's ultraviolet and there's infrared. Now, you can't see infrared, but how do you know it's there? You're going to learn this when you're in higher classes. How do you know it's there? You can't see with your eyes, but you can feel it. What do you feel when you're in the sun? You feel warm, don't you? That's infrared. That's infrared radiation. And when you sunburn, that's the ultraviolet part of the spectrum that does that, not the heat. It's the violet in it. Now, those colors, all those different colors, like a radio receiver, are different wavelengths. Each one is a different wavelength. Now, our eyes can only see a very small section of that. The actual spectrum, as we call it, is the whole, is enormous, and it includes radio waves. Radio waves tell us a lot more about the sun than the actual visual waves that we see. At the moment it might sound complicated, but you're going to learn about this. When you get into higher classes, you're going to learn all about this sort of thing. And you will know that one day somebody told you about this, and it's called the spectrum. Okay? What you can do is an experiment at home. It's very easy. You get a glass of water, a transparent glass. You fill it with water, and go outside and let the sun shine through that. Put your hand in, you'll see colors. Yes.
Sometimes with the sprinklers on.
Exactly. That's your own rainbow. You've made a rainbow. And how does the sprinkler work? There's lots of little drops of water, isn't there? It's just like rain. So the sunlight passes through those drops of water, and what do you get? Colors coming out the other end.
Sometimes when we're going to school, when the sun goes through the windows, we see rainbows.
Exactly. It's a spectrum. Any piece of bent glass, if it's slightly bent, will break the light up into those colors. In your school, they should have, or maybe they have. You should ask the teacher if they have if you have a piece of glass called a prism, and they should have. If you've got a science, you've got a science laboratory too. Not. And there's no laboratory. What a pity. What a pity. Okay. Well, what you do is you ask the teacher if there's a prism. P-R-I-S-M. And then, if the teacher, he or she says yes, it's a triangular piece of glass. Yeah, it looks like a little pyramid. You go outside and you let the light of the sun fall through that, you'll see the most beautiful rainbow. A diamond works on exactly the same principle. Why does a diamond sparkle? When you dig a diamond out of the ground, it doesn't sparkle. It's got to be cut. It's got to be cut in a certain way. And the people who cut it know that if the sunlight falls at a certain angle, it's going to give that beautiful sparkle that diamonds have. But in nature, diamonds do not sparkle. You have to make them like that.
Tony, will a prism in the pair of binoculars do?
If you want to break open a pair of binoculars, yeah.
For science,
Don't do that, Tito.
Don't do that,
Your dad's not going to be happy.
But yes, if you break open the binoculars, you will find
Don't do it.
prisms.
Yeah, but they said there we must do it.
The whole thing. Yeah, but I've never heard of chicken clock either.
Countdown.
What that is in fact, each pulse is 1 second. Exactly. Okay? Now, just listen. In 60 seconds, and of course you'll hear another tone.
It's like beep.
Okay. Now, what we do with this, I haven't done it now, but we normally connect that into this recorder as well. So every 60 seconds, it makes a mark. So that, you see, the trouble is doing an observation of anything astronomical. If you don't time it, it's a waste of time. You're doing nothing.
Okay.
So we've got to know exactly to the nearest tenth of a second what time an event has taken place. And we use this time signal generator.
Okay. Okay, so that just keeps time.
That's all it does. And you'll say, but there's no clock face. How do we know the time? You see, when you're looking through an eyepiece of a telescope, the clock face is no good because my eye's looking there. I can't look at the clock.
So you have to listen.
And sometimes events that you're looking at can happen in a tenth of a second. So what we do is we listen. We look at the nearest time, and then we count from there. Okay. So I know that the event happened in so many hours, so many minutes, and so many seconds. And then normally an assistant or somebody else, or electronically now today on computers, we just have an electronic marker that does the counting. Okay? As I said, what you're seeing here is a very simple system. Now, the interesting thing is, all this thing here, you can build yourself. That tripod is an old camera tripod that I got. That wood I bought spectacle at Builder's Warehouse. Those are brazing rods, or adults will know what brazing rods are. Those are just brazing rods. Okay, this is just aluminium that I bought. The radio receiver I had, I just converted it because I know electronics. That's what I do. But all of this is home built. Built everything myself.